Year 2021, month of March. This is a short presentation about uh, energy innovations that may affect all of us who work in anything that is accessory to electricity, and that would include software development. In the classic animated sitcom King of the Hill, the main character, Hank Hill, when asked what he did for a living, would say, "I sell propane and propane accessories." Hank Hill was a pretty simple man, but he understood the economy the way a physicist would. Energy first. All of computation as we know it is dependent on the electric grid. Since World War II, it has been, the electric grid at least, has been this, nuclear, natural gas, coal, primarily. We've added some renewable stuff since then, but it has still been mostly that, nuclear fission at least. However, by mid-century, we're going to see some other stuff peek through. And that's what the next slide is about. There will be effects in there's going to be higher demand for energy as more 3D metal printing comes out, as I've talked about before, like with the Cesinger project. And there's going to be more impetus for the next generation of nuclear fission reactors, but also nuclear fusion reactors. We have ITER in south of France, in southern France, in Aix-en-Provence. That'll be sort of the gold standard in the West for fusion reactors going forward. That'll be up and running maybe 2050s. But when that does happen, that's going to be a pretty big deal. And then, starting now and going into the future, we'll have more quantum computing that is very energy intensive to get the cooling system working for that. Quantum computing is not really the ultimate replacement of traditional silicon discrete computing. Quantum computing is basically the successor to analog computing. It's when you deal with systems, or you're modeling systems that are probabilistic rather than hard determinist in nature. Probabilistic systems rather than deterministic systems. So things like the weather, things like the stock market, possibly even maybe elections and democracies might be kind of this kind of weird probabilistic system. And so you have that. And then far future, antimatter reactors, inertia canceling, so you can drive very fast vehicles. If you ever had hovercrafts, you want something like that. And of course, the stuff we've rehearsed in science fiction, faster than light space travel, or wormholes that can take us to other points in space. These are big enhancements to the transportation industry. What we're seeing now with the whole automated cars and electric cars, well, first of all, electric cars aren't new. What's really new is battery technology. Stuff like performance per watt that we learned a lot about through the mobile revolution in just consumer electronics is the real innovation. Battery technology is the real innovation. And all these cars and stuff are just accessories to those battery innovations. And how those batteries charge Uh, we're gonna That'll be the reason we have the innovation in modern nuclear fission, uh, and eventually nuclear fusion. And you could splash some renewables in there if you have like some. I think renewables are are going to be used more for vertical integration. So like some big companies like Google, like Apple, they have their own energy grid for their own stuff. Possibly you might see that with some chain of uh, car charging stations in the future. We'll just have to wait and see. And so, by thinking like Hank Hill, we can begin to really see the structure of the future. You start with what is the energy conversion system you have, and then everything else is going to be accessory to that. And those of us who make software for these computers that are electromagnetic, we are going to need to, in some applications, be uh, very considerate about that performance per watt, that whatever we're doing uh, is considerate of that, and that in applications where we are plugged into an outlet, that uh, we don't assume that we're always going to be plugged into an outlet, because like something, the software that runs the server farms for Google or something, uh, the software component can make a huge difference in the energy consumption of a big server farm. So you do have to make those considerations when you scale up a program. So let's go off and keep adding value to silicon, uh, qubits, and whatever is driving our electric grid, because we are accessories to that. Thank you.